Welcome to Surds Level 1, one step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic by topic playlists on the channel homepage. In problem 1, we're simplifying the square root of 12. Now to do this, we need to find two numbers that multiply to make 12, where one of them is a square number. And if we look at our list of square numbers greater than 1, we can see that 12 can be divided by 4, and 4 is the largest number on that list. So we can rewrite 12 as 4 multiplied by 3. Now this means that the square root of 12 can be written as the square root of 4 multiplied by the square root of 3. And because 4 is a square number, we can square root it, and the square root of 4 is 2. So this becomes 2 times the square root of 3. And since we can't split 3 up into any other numbers on that list, we've simplified this completely. So our final answer to problem 1 is 2 root 3. In problem 2, we're simplifying the square root of 98. Again, to do this, we need to find two numbers that multiply together to make 98, where one of them is a square number. Now looking at our list of square numbers greater than 1, we can see that 49 is a factor of 98, because we can write 98 as 49 multiplied by 2, and that's the largest number on this list that will divide into 98. So this means that the square root of 98 can be written as the square root of 49 multiplied by the square root of 2. And because 49 is a square number, we can square root it, and the square root of 49 is 7. So we have 7 root 2. And because we can't split that 2 up anymore using any numbers on the list, 7 root 2 is simplified and is our final answer to problem 2. In problem 3, we're simplifying 4 times the square root of 50. Now ignoring the 4, we can simplify the root 50 by finding two numbers that multiply to make 50, where one of them is a square number. And looking again at our list of square numbers greater than 1, we can see that 50 can be divided by 25, and that's the largest number on the list that will divide into 50. So we can write 50 as 25 multiplied by 2. And this means that 4 root 50 can be written as 4 multiplied by, and we can split the root 50 into root 25 times root 2. Now the reason we wanted 25 to be a square number is that we can square root it, and the square root of 25 is 5. So this becomes 4 multiplied by 5 times the square root of 2. And because 4 times 5 is 20, 4 times 5 root 2 is 20 root 2. We can't split this 2 up anymore using any square numbers, so this is fully simplified, and our final answer to problem 3 is 20 root 2. In problem 4, we're simplifying 5 multiplied by the square root of 180. Now to simplify this and focusing on the square root of 180, we need to again find two numbers that multiply to make 180, where one of them is a square number. Now looking at our list of square numbers greater than 1, we can see that 180 can be divided by 4. Looking at the other numbers though, it's not really clear whether any of those can divide into 180 or not. And at first glance, it doesn't seem like they can. So we can start with 4. And we can write 180 as 4 multiplied by 45. So that means 5 times the square root of 180 can be written as 5 multiplied by the square root of 4 times the square root of 45. Now the square root of 4 is 2, so this becomes 5 multiplied by 2 root 45, and because 5 times 2 is 10, this becomes 10 root 45. Now the question here is, can we split the 45 up again and simplify further? And so we need to know whether 45 can be divided by any of the numbers on our list of square numbers greater than 1. And it can, because 45 can be written as 9 times 5, and 9 is on our list of square numbers. So this means that 10 root 45 can be written as 10 multiplied by, and we can now split the root 45 up into root 9 multiplied by root 5, and the square root of 9 is 3. So this becomes 10 multiplied by 3 root 5. And because 10 times 3 is 30, this now becomes 30 root 5. Now because 5 is a prime number, we can't split it up any further. and this means that 30 root 5 is our final answer to problem 4. It's also worth mentioning that if at the start we'd noticed that 180 can be written as 36 times 5, where 36 is on our list of square numbers, we could have rewritten 5 times the square root of 180 as 5 times the square root of 36 times the square root of 5. And because the square root of 36 is 6, this becomes 5 times 6 root 5, and 5 times 6 is 30. So we get 30 root 5, which is what we got the first time, but this was slightly quicker. Having said that, it does require us to spot that 36 is a factor of 180, and that's quite a tricky thing to do. So the first method is still a really good way of doing this. That's the end of problem 4.